Hello guys, welcome back to my channel. My name is Sri Pranav, bearing the USN 1V21IS053. Today we're gonna learn about allocation methods in operating system. Now let's see the contents that we are going to learn today. Introduction, memory management in OS, contagious allocation, non-contagious allocation, comparison between contagious and non-contagious allocation, fixed partition allocation, dynamic partition allocation, buddy memory allocation, pagging, segmentation, virtual memory allocation, and finally conclusion. Introduction: Allocation methods in operating system refers to the technique used to manage and assign resources to various processors or entities within the system. These resources can include memory, CPU time, disk space, and other hardware or software resources. Allocation methods plays a crucial role in operating system, especially in managing and optimization the use of resources. These methods are used to distribute resources such as memory, CPU time, and storage efficiently among various processors and users. Allocation methods in context of computer science and operating system refers to the technique used to distribute resources among computing processors or tasks. These allocation methods serve significant objectives to ensure efficient and fair resource utilization. Now let's look into the memory management in operating system. Memory management is a crucial aspect of computer system that involves organizing and coordinating computer memory resources to ensure efficient and effective utilization of available memory. It is essential for operating system to handle memory efficiently to provide a stable and responsive environment for running applications and services. Memory management is modern operating system is a complex task and is usually handled by operating system kernel. The kernel implements various data structures and algorithms to keep track of memory usage and control the allocation and deallocation of memory resources. The specific memory management techniques employed may vary depending on operating systems, designs, and the hardware it runs on. Efficient memory management plays a vital role in overall performance and stability of a computer system. This is a representation of a memory management system where there is a main memory and a secondary memory. The process from the main memory and the secondary memory is swapped in and out through the main memory by via user space of operating system. Now let's look into the contagious memory allocation. Contagious memory allocation is a memory management technique used by the operating system to assign and manage memory to processors and programs running on computer. In this allocation scheme, each processor is located a block of memory that is located in consecutive sequence of physical memory address. The contagious nature of the memory blocks simplifies memory access and management of both the operating system and the processors. Contagious memory allocation was commonly used in older operating systems and is still employed in certain embedded system or real-time environment where memory management is simplicity and efficiency are critical. However, in general purpose operating system, dynamic memory allocation scheme have become more prevalent due to their ability to handle complex memory demands and reduce fragmentation. Now, this is a design of contagious memory allocation. Non-contagious memory allocation is a memory management technique where a processor or program is allocated memory in on non-adjacent or scattered block rather than its continuous and contagious manner. In contrast, contagious memory allocation assigns memory blocks that are located next to each other in physical memory. Non-contagious memory allocation provides more flexibility. It also introduces complexity in memory management, such as page faults, extra overhead in maintaining page tables or segment tables, increased memory access time due to scattered data. As a result, operating system and memory management system need to strike a balance between contagious and non-contagious memory allocation. Technique based on requirement of running process and the available hardware resources. Now let's look into the design of non-contagious memory allocation. It's scatteredly arranged. Now let's look into the comparison between contagious and non-contagious. Memory allocation strategy. Contagious. Memory is allocated in one continuous block. Non-contagious. Memory is allocated in multiple separate blocks. Fragmentation. Contagious. Prone to external fragmentation due to allocation of fixed sized block. Non-contagious. Less prone to fragmentation as smaller memory chunks can be allocated more flexibly. Memory management complexity. Contagious simple to manage all memories is allocated at once and does not require complex data structures to track multiple blocks. Non-contagious, more complex to manage requiring data structure to keep track of allocated block. Access efficiency, contagious, generally more efficient or accessing data as it involves accessing memory in a single continuous block. Non-contagious, slightly less effective due to scattered memory locations that may require addition overhead to access data. Memory utilization, contagious, may lead to inefficient memory utilization over time due to external fragmentation. Non-contagious generally result in better memory utilization as it allows more flexible allocation of memory chunks. Let's look into the fixed partition allocation. In operating system, fixed partition allocation is a memory management technique used to allocate memory to processors in a system. It was commonly used in early computer system and is now mostly seen in embedded system or specialized environment where resources are tightly controlled by dynamic memory management is not necessary for feasible. In fixed partition allocation, the memory is divided into fixed size partition, each capable of holding one processor. When the processor is loaded into memory, it is placed into a partition that has enough space to accommodate it. Once the partition is allocated to the processors, it its sizes remains fixed and processors cannot expand beyond that limit. If a processor is required more memory than the partition size, It cannot be loaded, which can lead to internal fragmentation. Now let's see the representation of dynamic partition allocation. Now let's look into the dynamic partition allocation. Dynamic partition allocation refers to the memory management technique used in computer operating system to allocate memory to processors and data dynamically at runtime. It is commonly used in modern operating system to efficiently manage memories and support multiple running processors simultaneously. In dynamic partition allocation, the available memory is divided into variable sizes partitions. Each partition is assigned to a processor or data segment based on its size requirement. When a new processor or data segment needs memory, the operating system searches for a suitable free partition that is large enough to accommodate the processors or data. The choice partition is then allocated to processors and informed about the allocation in is recorded in a data structure called memory management unit. This is the representation of dynamic partition allocation. Now let's look into the body memory allocation. Body memory allocation is a memory management technique used in operating system to efficiently allocate and manage memory blocks of various sizes. The system uh, divides available memory into fixed blocks that are powers of 2. Each block is considered a body to another block of same size. When a memory request comes in, the system finds the smallest available block that can accommodate the request, splitting larger block if necessary. When a block is deallocated, the system checks if its body is also free and merges them into the larger block, reducing fragmentation. Body memory allocation minimizes the fragmentation, ensures faster allocation and deallocation, and simplifies memory management. However, it incurs overhead when memory requests are not in powers of 2, leading to some internal fragmentation. Despite this, body memory allocation remains a popular choice of certain systems, especially those with real-time and embedded requirements. Pagging. Pagging is a memory management technique used in operating system to implement virtual memory. It involves dividing the logic or virtual memory of process into fixed size block called pages and dividing physical memory into blocks of small size called frames. The main goal is efficiently used memory by loading only the required pages of processor into RAM, allowing multiple processors to share the available memory. The mapping between virtual pages and physical frames is maintained by data structure called page table. Pagging provides benefits such as virtual memory protection, efficient memory utilization, and simplified memory management. However, it is also introduced some overheads, including page faults and additional memory lookups to optimize performance. Operating systems uses techniques like prefetching and replacement algorithm. Overall, pagging is a fundamental concept in modern operating system, enabling efficient memory utilization and fa- facilitating the execution of larger programs. Segmentation. Segmentation is another memory management technique used in operating system alongside pagging to implement virtual memory. Unlike pagging, which divides memory into fixed sizes blocks, segmentation divides the logical or virtual memory of a processor into variable size segments. Each segment represents a meaningful unit of the program, such as code, data, stack, or heap. The segment memory model, the segment are not required to be of the same size, and they can grow or shrink dynamically based on the needs of processors. Each segment is identified by a segment number and an offset within the segment, forming a virtual address that the processor uses from memory access. In the summary, segment is a memory management technique that divides the virtual memory of processors into variable size segments, providing logical organization, protection, and dynamic memory allocation. However, it can suffer from fragmentation and segmentation violation. Modern systems often combine segmentation with tagging to address this issue and achieve a more efficient memory management solution. Vir- Now let's see the virtual memory allocation. Virtual memory allocation is a memory management technique used by modern operating system to create an illusion of large memory than physically available RAM. It allows each program to have its own isolated and contiguous address spacing, simplifying memory management for both the operating system and applications. Virtual memory divides the logical or virtual memory of a process into fixed block or variable sized unit. When a process accesses memory in its virtual address space, the operating system handles the translation of virtual address to a physical address using data structures like page table or segment tables. If the required page or segment is not present in physical memory, a page fault or segmentation fault occurs, and the operating system brings the required data from secondary storage into RAM, and swapping of pages between RAM and disks allows multiple processes to coexist and run large programs than what the physical memory alone could support. Overall, virtual memory allocation is a crucial mechanism in modern operating system, enabling efficient memory utilization, memory protection, and supporting the execution of large and more complex applications. At last, the conclusion. Allocation methods are essential aspects of various processes, ranging from resource management in computer system to decision making in economic and social content. The conclusion of allocation methods can be summarized as follows: efficient, fairness, trade-offs, optimality, application specific, algorithm complexity, dynamic environment, transparency, and accountability. In the conclusion, allocation method plays a vital role in resource management, decision making, and distribution process across various domains. The choice of appropriate allocation methods depends on the specific goals, constraints, and characteristics of a problem at hand. Striking a balance between efficiency, fairness, and other objectives is a complex and nuanced task that required careful consideration of the application context. Thank you for watching. Please do share, subscribe, and do like the video.